Okay, I'm kind of reading. It says, rectangular swimming pool with a length 20 meters. Let me put that down for you. 20 meters. A width of 12 meters. I'll put this over here, 12 meters. Rectangular swimming pool, right? So something like this over here. A depth of 2 meters. The reason I'm drawing a picture, by the way, is not to, saying I need to do that, but in some sense I do need to do it. And this is 2 meters. All right? So rectangular swimming pool with a length of 20 meters, 12 meters, depth of 2 meters is filled with water to the 1.7 meter mark. So I'm going to put this over here. This is where the water's filled to. And that's the 1.7 meter mark. All right? And I think I know what they want to do. They want to pump the water out and how much work is required to do that. And let's talk about that. And again, this relates back to that hydrostatic problem. And I think we've already determined from that problem in the prior, I can't remember, number 18 or something, I just don't remember what number it was, that the water, that it was 1,000 kilograms per meter, cubic meter. We just derived that a while back, by the way. And what I'm going to do, I'm doing the same thing. I'm doing a sliver. And I'm going to do the sliver like this over here. And let me just put a coordinate system in. I'm going to say it's the y-axis and this the x-axis. All right? I'll do that sliver. And I want to do the volume of that sliver now, because we need to pull that water out of the tank, by the way. And I got to look at it. You got to be careful here. So that sliver is going to be 20 times 12. And the differential is going to be dy. This is the y-axis, by the way. So I'm pretty comfortable that the volume there is 20 times 12 dy. And now I'm going to do the water. And what I'm doing now is the density of this thing times the acceleration due to gravity. It reminds me of that last problem we did. And that was 9.8 meters per second squared. What does that give you? 9,800 kilograms. And then you can get meters squared per second squared. All right? And by the way, over here, this is a volume, so it's meters cubed. All right? And then what I'm doing now, let me write that down for you, 9,800. Get that part done. It's got to be lifted, the water. And it's being lifted through a distance. And the distance is, the bottom line, I got to take all the water up. And it's got to be taken to the top of the tank, by the way. So what I'm going to say is it's really the distance that I'm pumping it out. The most it could be is 2 meters, by the way, get to the top of it. So I'm going to say 2 minus the y value. Then the question is, what are the numbers? All right? Well, I'm going to say 0. The reason being, if I'm at 0 and I plug it in, 2 minus 0 is 0, I definitely pull up 2 meters. And then where is it stopping? Well, 1.7. And let me tell you why it's 1.7. Because 2 minus 1.7 is 0.3. And that's that top sliver of water. I got to pull it up 0.3 meters, by the way. So I'm pretty comfortable I got this over here. And what I'm saying is I got the integral. Let's just take a look. And I want to see if I have this stuff written down for you. So do I have the dy? I do. Do I have the 12 and 20? I do. This is 9,800. I see that. I see the 2 minus y. And I see this over here, 0 to 1.7. All right? Now, over here, I noticed that I did an exact integration, and I really think that you should be using a calculator because the numbers, I'm not saying they're terrible, but it does require some arithmetic skills that I'm too tired to do right now. But again, you should get this number over here. Do I see that number? I do. What's the unit on that? Joules. Okay, so I want to just say we do give you sort of like a verbal walkthrough of this over here. And They will also talk about what a joule is and stuff. But for the most part, you can read through that stuff. I'm not terribly interested in it, but you could read through it, and it's not a bad idea to read over that stuff. Are you going to remember what you read? No. But I want to point out a joule is equal to 1 Newton meter, all right? So over here, again, set up the integral. It's probably the single most important thing to do. It's also probably the most difficult thing to do. After you set the integral up, I would recommend using a calculator, because really the whole point of this problem was to set the integral up. It really is the toughest thing in the problem, by the way. Thank you.